Hello class, we continue reviewing for exam 3. Question number 11. Yeah, I notice this trinomial, the last term is 225, which is the square of 15. So this trinomial actually is a perfect square trinomial. The first base is x. The second base is 15. And if we multiply the two bases together, 15x, and double it, we have 30x, which is in the middle, right? So that proves this trinomial is a perfect square trinomial. Since in the middle we have a positive, the result is going to be a difference. Sorry, it's going to be a square of a binomial sum. First base x plus the second base 15. It's going to be square of x plus 15. You can double check by using for you or box method. Question number 12. Using the factoring method, solve for the root of the quadratic equation. All right, let's see. Okay, so there are multiple ways to solve this equation. Since we mainly focus on solving by factoring, this is what we do, okay? 4x squared equals 64. And you should notice 4 goes into 64 16 times. So we divide each side by 4 to get rid of the common factor 4. We have x squared equals 16, right? And then we minus 16 from each side. We have x squared minus 16 equals 0. And right side is 0, left side is the difference of two squares, which can be factored as x plus 4 times x minus 4 plus 4 minus 4, right? Okay, then the two solutions is going to be -4 and +4. That's it. -4, comma, +4, right? Use a comma to separate the answers. Two solutions. Next, factor by using either, obviously this equation is a perfect square trinomial. 49 is 7 squared, 64 is 8 squared, right? 7 times 8 is 62, double it is 8 times 7, 56. 56 double it is 112, yeah. So we are going to have a square of a binomial sum because the middle term is positive. It's going to be 7a plus 8b. Double check. 7a is the base of 49a squared. 8b is the base of 64b squared. 7a plus 8b. Okay. Number 14, factor. Yeah, just forget about those methods. I think the method I teach in the class is easier to use. So let's see, 5x squared minus 34x minus 7. GCF is 1, right? So we're gonna actually, in fact, all the three coefficients are prime number. Well, so we are going to apply slide divide slide method. Slide divide slide method. We have x squared minus 34x minus 35. 5 times 97, negative 35. Factor the two integers multiply to negative 35, add up to negative 34 or negative 35 and plus 1. Negative 35 times 1, negative 35. Negative 35 plus 1, negative 34. Divide the two numbers by the leading coefficient 5. Simplify. 35 divided by 5, 7. So negative 7. And here we have 1 over 5. Slide 5 in front of x within the parentheses. So the factorization is x minus 7 times 5x plus 1. Parentheses. X minus 7 in the first parentheses. 5x plus 1. 5x plus 1. X minus 7, 5x plus 1. Question number 15. Factor by first looking for the GCF. That's a good reminder because this trinomial GCF is 3, right? 27 y squared. Knowing this trinomial is an invariable y, we would have to write y. GCF is 3, so we factor 3 out. We have a 9y squared plus 12y plus 4. And I notice the trinomial in the parentheses is a perfect square trinomial. We can double check. 9y squared has a base. Base 1 is 3y. Oops. Right? 3y times 3y is 9y squared. And the last term is 4, which is 2 squared. So the second base is 2. Multiply them together, 3y times 2 is 6y. Double it is 12y. So it's in the middle. So it is a perfect square trinomial. So the result is going to be a square binomial sum. 3y plus 2. Okay? So the answer is going to be 3 times 3y plus 2 to the power of 2. You might wonder, could I enter 3 times 3y plus 2 times 3y plus 2? Yes, I think so. Same thing, okay? We have 3, and then multiply by parentheses to the power of 2. 3y plus 2. Double check its entry. 3 times 3y plus 2 inside the parentheses to the power of 2. Okay, next. Question number 16. Okay, this one, it reminds you to factor GCF out, right? Yeah, we should do that. 50, 5, negative 10. GCF is 5. And we have x in common, right? So 5x is GCF. Let me write down the trinomial. 50x cubed plus 5x squared y minus 10xy squared. GCF is 5x factored out. If you don't remember how to factor it out, I can repeat the process right here. Original term 1 over GCF plus original term 2 over GCF plus original term 3 over GCF. Simplify in the next step. 10x squared plus xy minus 2y squared. We can double check, right? Yeah, 5 times 10, 50x cubed. Here we have 5x squared y minus 10xy squared. Okay, very good. And then what do we do in the next step? We could use the slide divide slide method to factor the trinomial inside the parentheses, okay? We can do that. Remember, how do we process that? 10x squared plus xy minus 2y squared. In the class, I introduced a method. We get rid of y first. This method only applies when the 3 terms all have degree 2. This one is x times x. This one is x times y. This one is y times y. Only when the trinomial has that form, we can do this. After we remove y, we have 10x squared plus x minus 2. Okay, then we do slide by slide. X squared plus x minus 20. Factor x plus 5, x minus 4, right? 5 and negative 4 times 5 and negative 4 multiply to negative 20, add up to 1. And then divide the two numbers by 10. We have x plus 1/2 here, and here is x minus 2/5. And then slide back. We have here, and then a 2x plus 1, and 5x minus 2. Okay, now we are going to bring y back, right? Yeah, 2x plus 1 times y, and 5x minus 2 times y. Oops. 2 times y here, okay? So now we put it back. The trinomial inside the parentheses can be factored as 2x plus y times 5x minus 2y. I can double check very quickly. By FOIL or box method, right? 10x squared, negative 2y squared. 5xy, that is negative 4xy, so it's 1xy. Yeah, that's correct. This is the answer. This is the easiest way that you can process this type of trinomial, okay? Back to this type of trinomial. GCF 5x, and then follow with two parentheses. In the first parentheses, we have 2x plus y. Second parentheses, we have 5x minus 2y. 5x minus 2y. Yeah, make sure you double check your entry. I always emphasize that if you mistakenly, enter something wrong, you wasted the whole effort, right? Okay, next, question number 17. Factor by factoring out GCF, okay. 15, 25, 10, GCF is 5. 15x squared minus 25x minus 10. Factor 5 out. We have 3x squared minus 5x minus 2. Okay, so how do we factor this trinomial? We're gonna do slide divide slide method, okay? So 3x squared minus 5x minus 2, slide, x squared minus 5x minus 6, factor, x minus 6, x plus 1. Negative 6 times 1, negative 6. Negative 6 plus 1, negative 5. Divide by 3, which is the leading coefficient slid away, right? Simplify x minus 2, x plus 1/3. Slide it back, x minus 2, 3x plus 1. Put it back. Put it back. 5 is GCF. And we have x minus 2, 3x plus 1. I would say those pretty challenging, right? 5 times x minus 2 times 3x plus 1. That's the final answer. Put it here. 5 is GCF. Follow with the two parentheses. In the first parentheses, we have x minus 2. In the second parentheses, we have 3x plus 1. 3x plus 1. 5 times x minus 2, 3x plus 1. Okay, next. Question number 18. Let me look at this trinomial. GCF is 1. There's nothing to factor it out. Slide divide slide method. 15x squared minus 3x plus 5. Slide. X squared minus 3x plus 75. Yeah, 15 times 5. 75. Okay. Let's see which two negative numbers multiplied to 75 add up to 93. Okay, we do have to go through the process, right? Yeah, x squared minus 3x plus 75. When we slide 15 times 5, 75. A is 1, B is negative 3, C is 75. Since the two integers need to multiply to positive 75, add up to negative 3, they need to be both negative. And which two negative numbers? We factor 75. 1, 7, 5. 2 doesn't work. 3, 25. 5, 15. Yeah. 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's all the possible ways to factor. But none of them, since both have to be negative, none of them add up to 93. This is not factorable, okay? We went through the process and we noticed there are no such two integers multiplied to 75 add up to 93. So the polynomial is not factorable. It's fine. Question number 19. Okay, this one, difference of two squares formula, right? Obviously. Is the difference of two squares. First, the base, 6x, okay? Yeah, 36x squared, base is 6x. Second term, I have to make it smaller in order to see the whole picture. Second term is going to be 5 squared y squared, so the base is 5y. So 6x plus 5y, 6x plus 5y, second parenthesis, 6x minus 5y, 6x minus 5y. 6x plus 5y, 6x plus 5y, 6x minus 5y. That's it. Next. Question number 20. For sure, the first thing to do is GCF, right? Because you can see x is common, y is common. 8 goes into 32 4 times. Let me copy the trinomial. 8x cubed, y cubed, minus 32, x squared, y cubed, plus 32x, y cubed. So every term has a y cubed in it. All right, so the GCF is what? 8y cubed. Factor it out. And if you don't know how to write a content in the parentheses, use the process I teach in the class. Term 1 over GCF plus term 2 over GCF plus term 3 over GCF. 8 cancel 8. 8 cancel 8. Y cube cancel y cube. Hold on a second. Oh, my bad. There's x. There's x here. X is common. X, my bad. So factor x out as 1 because every term has x in it. So the GCF, excuse me, on this, all covered up. HXY cubed. Okay. HXY cubed. So 8 cancel 8, x cancel one of the x in the numerator, so we have x squared. Y cube cancel y cube. And in the middle term, negative 4. 4 times 8 is 32, right? And x in the numerator, because x squared over x is 1x. Cube cancel cube of y, and this one is 4. X cancel x, y cube cancel y cube, so we have just 4. And this trinomial in the parentheses is a perfect square trinomial, x minus 2 to the power of 2. All right, the GCF is 8xy cubed. So let me rewrite this part just to make sure you see it better. GCF is 8xy cubed. 8xy cubed. 8xy cubed. And because they all have x in it. All right, so the answer is A. Factorization is 8x, oops. 8xy cubed times parentheses to the power of 2. Inside the parentheses is x minus 2. Okay, double check 8xy cubed, x minus 2 to the power of 2. Okay, all right. So that's number 20. I'm gonna see you in the next video, cover the next 10 questions.